All right, so in this lesson, we're going to talk about something called inductive reasoning and then how to make a conjecture. We'll also look at how we determine whether a conjecture is true or false. Okay, so what is inductive reasoning? Inductive reasoning is the process of making a conclusion based on observation and patterns. And so you're going to look at what's happening, see if you notice any patterns, and then make a conclusion from that. Okay. The concluding statement, your conclusion, is called a conjecture. And this is something that you have figured out by looking at patterns, and that is called inductive reasoning, as we just said. So, for example, let's say I give you a sequence and I ask you to find the next three terms. You're going to look at the pattern and see if you can see what's happening, and then you can write your conjecture. So in this particular sequence here, we have A, D, G, J, and so what you want to say is, what's going on here? Well, you can see, let me switch my pen here. Between here, we can see that there are two letters skipped. So I have A, B, C are skipped, and then D. So D, E, F, and then G. And then G, H, I, J. So K, L, so this would be M. And then N, O, P, Q, R, S. So each time we're skipping two letters. And that's how we get our next term. So our conjecture would be to find the next term. Let's write it out. Skip two letters from the previous term. And that is our conjecture. That's what we determined is the concluding statement. And that's really, that's kind of it for that. So then the pattern sometimes can get harder, but ultimately you're still doing the same thing. So if we look at this, here is another one, same process and same directions. You see 1/3, 2/4, 3/5, 4/6. So then what's happening each time? It looks like every time in the numerator we're increasing by 1. And we're also doing the same thing in the denominator. So if that's the case, then the next one here should be 5/7, and then 6/8, and then 7/9. Those will be my next three terms. So what is the conjecture? To find the next term, add 1 to the numerator. There we go, to the numerator, to the top, and 1 to the denominator. And that would be our conjecture. Okay, I hope that's making sense. All right, one more. So if we look at this, find the next three terms in the sequence and then write our conjecture. We see a triangle, we see a square, and then a pentagon. So this, all the sides are the same, they appear to be. So this looks 3 sides, 4 sides, 5 sides. So what we want to do then is we need one with 6 and one with 7 and one with 8. Now, you'll notice these sides are all congruent. So as best we can, we want to try to draw what is called a regular polygon as best we can. We might. Okay, that's not terrific, but you get the picture. And then okay, that's 7. And then I don't know if hopefully we can make 8 work here. It's going to look probably a little, with this iPad pen that I have, is not the best. Okay, that looks pretty terrible, but it's supposed to be an octagon as best we can. Now, what is our conjecture? So our conjecture is to find the next term. Let's say create or draw, if you want to write that, create a shape with one more congruent side. Okay. And that's how you write a conjecture. Okay, so let's look at some conjectures and determine if they're true and false. Just because you see a conjecture doesn't necessarily mean that it's true. So if you can show a counterexample, that's simply an example where the conjecture is false. If you can show one time where it's not true, then that conjecture is false. So, birds can fly. That would be a conjecture. That is false. And why is that? Well, because not all birds can fly. One counterexample is penguins. You could also say ostriches, but penguins can't fly. And so there's a counterexample. Okay. The sum of 2 consecutive whole numbers is always odd. So when we say consecutive, so like 2 plus 3. 2 and 3? 5. Okay. What about 3 and 4? 7. How about 4 and 5? That's 9. Okay, this appears to be holding true, and I'll do another one here. You can pick any ones. Let's say you did 30 plus 31, right? That's 61. That's odd. So this is a true statement. Any 2 consecutive whole numbers, if you add those together, you'll always have an odd number. That's true. Okay. All state names have at least 2 syllables. So like Minnesota has more than 2. Min-so-ta, that's 4. So this is true almost always, but there is one exception. One time where it's not true, and so it's false. And that one state that does not have 2 syllables or more, crazy as it is Maine is the only one that doesn't have 2 syllables or more. So this This is close to being true, but it's not quite. And again, if you can find just one time where it's not true, then it's the conjecture is false. And that is the lesson for this. So it's a good idea to just kind of always summarize your notes and then give this assignment a try. All right. I hope that makes